Okay, so let's do a very easy and detailed introduction to functional programming, um, but without any terminology and just with intuition, right? Um, so I am going to be speaking to you, the listener, directly now, throughout this video probably. So hi listener, how's it going? I'm cool, thanks. Oh, nice. Okay. Okay. So I, for the purposes of this talk, I will be, this guy, right? Um, inside the computer, right? And you're outside. You're like, you know, there, but like in 3D, right? So, how do I draw this? It's an arrow, right? You're like there, but then if this is the z-axis, then now tilt that arrow in the z-axis a bit, right? So that this goes here, and then you can see it like up front. Anyway, you get it. I'm belaboring the point. So sure. So you're out there. I'm inside the screen. Cool. So let's start. So listener, let's say that you give me a box. I don't have one, so you give me one, and I need one. I'm moving or something, packing stuff, or I just need a box. So I go, hey, listener, you have a box? And you go, yeah. And I go, well, can I have it? And you go, yeah, man. And so you give it to me. So here's the box. It's an orange box, and that's cool because I think an orange box looks pretty cool. And then I say, can I customize it? And you go, sure. And then I just like put a dash of blue and make it look nice, All right. Okay. So you gave me this box, and before I didn't have one. Now here's the thing. Now I exist with this box, right? I'm holding this box right in front of you. Okay. And now I have this box, and you can remember that I had no box before. Do you remember before I drew this box? But it's only in your imagination, right? And that is now gone. It's gone from the world. And Peter now has a box, and there's no Peter without a box. So this is would we say that this is a new Peter? Maybe not, right? Because it's the same person. Like, I'm the same guy, right? But now I have a box. So it depends on the way you want to see it, right? So sure, in the real world, I'm the same Peter. Now, when object orientation wants to model the real world, maybe it goes a bit too far when it tries and model the fact that old Peter without a box doesn't exist anymore. And I know it sounds weird, but I'm going to rephrase this in a better way in a bit. But I want the impact. Okay. So object orientation is saying, well, because in the real life, Peter is the same Peter. It just happens that he has a box now. Then, so it should be in programming. So if I give a box to Peter, then Peter now changes, and he owns a box now, and that's just who he is now. He's the guy with a box. Okay, so let's relate this more to programming. Now, let's try and model this a different way. What happened here? I'm gonna draw that at some point there was me, and then there was me with a box. Right. Okay. So this is another way to look at what happened. So before, we were looking at what happened by making it happen, right? So I'm going to talk a bit like meta here, right? I'm going to be meta. What? Meta. That means I'm going to talk about things before, in the meaning that comes before, right? So not these things, but I'm going to talk about the fact that I was drawing them. So this drawing that I did for you, listener, this drawing that I did was one way to explain that you gave me a box, right? Was one way of explaining that this happened. Right? The fact that I drew a doll and then I drew the cube, right? That is one way of explaining that you gave me a box, right? We're pretending you actually gave me a box, right? And then now I'm saying that I drew you giving me a box as a way of explaining what happened. So, again, just to summarize, not to be confusing, but this is my point here. What I'm saying is, one way to model what happens in the real world is by actually making it happen, right? Then you can really almost like be exactly, you can be as precise as you want, right? So if the real world is like a perfect arrow, the way you model this can get as far or as close as you want, depending on how many lines of code you want to write, right? So if you're modeling like a 3D simulator, right? Physics simulator, then it depends on how close you want to get to reality, right? The complexity goes up. Okay. So in a way, sure. One way to model reality is simply by, so one way to model how things happen is by making them happen, right? So viewer or listener, I don't want to say viewer, so I call you listener. When you gave me the box, I then explained what happened through drawing, and that was an explanation that mimics reality very closely, right? Because you really gave me a box, right? And then I drew you giving me the box, and the drawing progressed through time. So the drawing changed through time, right? So the drawing within these boundaries didn't even exist when I started to draw, right? But the drawing within these boundaries changed over time as I was making things happen, right? And making things happen inside the box, in other words, drawing inside the box, was my way of explaining to you, viewer or listener, was my way of explaining to you that you gave me a box. We're pretending, right? We're pretending you gave me a box in real life, and I drew this event, okay? Now, okay, after all this convoluted explanation to make sure that you're all with me, not you're all with me, that you're with me. So after all this explanation to make sure that you're with me, let's go to this other way of explaining what happened, okay? So listener, here's another way of explaining what happened when you gave me that box. Okay, remember that box you gave me in real life that we're pretending you gave me, not the box I drew, but the box you were pretending you gave me. So here's another way of explaining what happened. I can say, well, there was a Peter without a box, and then there was a Peter with a box. Now, let's think about that for a second. So that's one way of explaining it. You see? There's some repetition there, right? Because, like, Peter, I had to draw Peter twice, right? Let's think about that. So I had to draw it twice. Now I could have done it like this, look. And then I copy it. Actually, I'm not gonna do this because on my copy paste clipboard I have all black so that I can reset the screen, and that's more useful to me. So I can just explain. If instead of drawing the second one, instead of drawing the second one, I actually copied it right here, right? So let's say I select this one and I copy it over here, right? So now pretend that they're like the same and that I copied them and I didn't actually draw it. So, and then I draw the arrow, and then I draw the box, right? So I could say, you know, I reached the same results, but I could tell you, I could say, well, sure, it seems like there's some repetition because this is drawn twice. However, I didn't draw it twice. I only drew it once, then I copied it. And this is, we're talking a bit about memory allocation here, if it's not clear. What I'm saying is, one way of representing how things change is to make a new one, a new copy, with the change, instead of changing the original. That's my idea, right? So my idea is, whenever we need to change something, we make a copy. So we select it, and then we move it over, and then we copy it here, right? I'm gonna try and draw like very close. Right, like this. So I copy it over here, and then I add the change, the box. Right? That is what I do. This is another way of representing what happened. Remember when you gave me the box? So I'm proposing that here's another way of drawing. Instead of drawing on top and changing what I drew so that the drawing changes over time, I can simply copy it every time I change it. That way, I can even go back and see where I came from. So, you know, because what drawing came from, you know, which drawing did this come from, right? This came from this, and that came from, where did it come from? It came from this, which came from this, right? So it's as if, you know, I drew a circle, so I can draw a circle and I can copy it and then draw a line, and then I copy and then make another change, and I copy, make another change, and I copy, make another change. And I could do this, right? And this is another way of explaining what happened. Except that when you gave me that box, I simply this is all we're interested in, is this thing that I drew the box on around, metaphorically. So this is what happened, right? But this stuff never happened. Like, I didn't get built, right? Before you gave me the box, like, I was just hanging out, and then, you know, you started to watch the video. But and you gave me that box, which was so nice, you know. And I really like orange and blue, so I really appreciate it, man. Or gal. So here are the steps then that I drew, but what I mean is I never got built, right? So this never happened to me. However, something equivalent happened to me. Like, I was born, and before I was born, I was like, and then, well, you know, a bunch of stuff happened, and but then, and here I am. But when you gave me that box, this is all that happened. Like, this, we can represent it just with this. It's fine, right? And so it's interesting because we could abstract all of this away when I had drawn just this, right? I did not have to explain to you, well, listen, I'm gonna draw this guy, it represents me, and but really it represents my being born and like all of my life, and like, what is me? Well, let's define who I am and who I really am, blah blah blah. Like, I don't have to explain who I am. I can just say, listen, this stick figure is me, okay? And you don't care, okay? I was just the guy that is explaining the thing, okay? Okay. So So I could abstract away from all of this that happened in my life, all of the history in my life. I abstracted away into the pronoun me, right? Or I, that I'm using. And the abstraction in the drawing was this stick figure. So this is me, right? Or this guy. And so the power of abstraction here can be easily seen with this representation of changes that I'm creating here, right? As an idea, right? That's my idea, is to represent the changes, right? And it's interesting because we know exactly what we can forget, and at each step we're fine. We can decide if we can actually forget that, or we can go, okay, I'm drawing this, whatever. From this point on, the meaning is different. Right. From this point on. So it steps through this boundary where the meaning changes and it becomes an actual person that is drawing this now, who is me. So that's what the meaning becomes, because this is not me without legs, right? This is nothing. I'm not done drawing. That's what this is. I'm not done. But this I'm done, and then I'm saying this represents me. Okay. Okay. What else? So what are the advantages of, because I'm defending this system of representing things as their changes, right? And why is this better? Well, one is, remember that I said that you had to imagine how I looked like without a box, right? Or who I was even. Maybe that changed me, right? Profoundly. And it did a bit, because, you know, the coolness of the box, it did actually change my life a bit. Like, I really like orange and blue now, and I want to get a box that is orange and blue. And just have it around. Maybe a cushion or something. All right. Okay. Well, where's my? All right. What else? Okay, so I'm defending the system of representing changes. So why is this better? Well, one is you don't have to imagine anymore what I looked like. You can clearly see what I looked like. So it's more explicit, right? It's a lot more explicit what happened here. And at any time, you can look at it, and you get the same information. So, you know, before, as I was drawing this guy, I'm gonna use the airbrush a bit, make it fancy. As I was drawing this guy, right? I was changing it, and depending on at each point in time, like if a person came in and looked over your shoulder, they could see that in different points in time, right? It could be that they came in and they saw it as I was drawing the head, and then another person comes in and what they see is only starting from the torso, right? And then the third person comes in and what they see is they see the full figure started already, but they don't see the box. And then another person comes in and all they see is the already product, which is the guy in the box, right? So these people see different things, and they have different information. They've gained different information, right? Because their information started. What they get is what it starts with, right? So what they got is the first person got just the head, second person head and torso, third person head, torso, legs, and the fourth person head, torso, legs, and arms and box, right? So they got different information. But if the same people had come in as I was drawing this one, right? As I was drawing that one, but they wait around till I'm done. But they can arrive at any point, right? But they wait. They wait till I'm done drawing. Because that's the rule now that I'm going to introduce. That whoever comes in needs to wait till I'm done drawing. At least one idea, right? To make my example work here. But also because this is explaining something else, a concept called laziness. That will be introduced much further. But this is a good intuition to build now. So then they stick around, and when I'm done building, then they all see the same thing. And they all understand what happened. And they all get all the steps. It's a lot more explicit. So there's an advantage there, right? Now, always pretend I'm not redrawing this, right? I'm always copying, right? So I'm pretending that I drew this, and then I copied the head, and then I drew the torso, right? So I never draw the head twice. And then I copy the head and torso, and then I drew the arms, right? And then I copy them, so I never draw the head and torso twice, right? So I never draw anything twice. So I end up only drawing exactly what I would have drawn, except that it's as if the computer is saving each time I draw something and let the pen go. It saves another frame and then lets me start again. And then I go, now I want this. And then it goes, okay. And then I go, now I want this. And then it goes, okay. And then I go, yeah, well, and then I go, now I add arms. And it goes, okay. Then I go, now I add box. And then it goes, okay. Alright, and then it's ready for the next change. So this is a cool difference. Cool difference. Let's see if I can make this point clearer. Okay. So the point is, never change the original. Never change the original. So that's the lesson that we learned here. If we never change the original, we always know what happened. And we can go back and analyze it. And you know what? Maybe if we have all these pictures, we can start copying it again. And from here, start drawing something else. Etc. and so on. So that's cool, right? Because we save a lot there, because then we really start seeing some benefits over drawing on top. Because now we can actually go back to a previous state and then start over from there. We can pick up from any point in time. There's some really cool benefits to this. Okay. So the lesson is never change the original. So let's see what the implications of this lesson are. Okay. So let's say we see that it's a good thing to never change the original. I mean, at least it sounds reasonable. It doesn't sound crazy. And we can clearly see what the benefits are, right? Okay. Now, if you never change the original, let's go back to how to model the mouse, right? The mouse is a class that has two instance variables, x and y. This is like at least, right? This is just the part that I want to talk about. So a mouse is a class that has x and y. And those are variables that change over time. But that's not what I wanted to say. We were going to talk about the implications of okay, the implications of the fact that we're not going to change the original. So here are the implications. If we're not going to go change the original, then let's go back to the mouse implementation, right? That's what I was going to say. Now, we don't have a reason to have x and y as instance variables anymore. Why? Because then in set position, we won't be able to assign you know, this is horrible. Okay. Yeah, this is not the set position. This is update. Okay. Redeem myself a little there. Okay. So there's no reason to have instance variables anymore because we can't change it. You see, this would be impossible if we are to abide by this newfound lesson that don't change the original, right? Don't change the original. Cool. I don't think we saved too much, but whatever. Okay, so don't change the original. So we can't change anything. So we can't have an instance variable. So how are we going to do this? Okay? There's no way. If you can't change it, you can't model this, right? Well, we're going to have to find a way around it because we still want to move the mouse. We can't anymore because you know, things are, we can't change them anymore. Okay, so how do we resolve this situation? How can we model the mouse if we cannot change anything? So remember, this class we wrote as an actual implementation of a mouse that we had built or something, right? Or we bought, and there was no driver for it. So we're writing the driver for the mouse, right? And this is the OO implementation of it. Looks like this, right? Has a set position and has an if, right? If within screen boundaries, right? Yeah, let's not forget. Let's make it very ugly. And if not inside the screen boundaries, right? Which makes the code very ugly. And and because this is an OO system, that's what I mean to say. Because this is an OO system, the entire system is OO, then we're simply promised that the Oracle, in our case here, is the runtime that we're programming against that is also the operating system. We're guaranteed or promised that the runtime, whoever that is at the time, will call the function that we name setPause, right, with the delta of the mouse, right? So remember that that is what we wrote. Let's have that very clear, that we bought a mouse, wrote a driver, because we were promised that the operating system, when we plug in the mouse, the Oracle said, okay, I see your mouse, and every time it moves, I will send a triangle to a function that you define inside a class called mouse, and to a method called setPause. To that function, I will send a delta, and you can do whatever you want with it. And then it just so happens that what you do is you change the state of your class, right? And then there's another contract with the Oracle. The Oracle says, okay, I will always make it so that the mouse is whatever is in X and Y inside your class mouse, right? So that is the contract the Oracle has with you. That's another contract, another promise. The Oracle promises to always set the mouse, make sure that the mouse is wherever the X and Y is, right? So that should look a bit strange now that I'm going to introduce the way to do this without objects. So I'm gonna start to point out what is strange about this from my perspective, from the perspective of a functional programmer. So what starts to look strange here is, or not a functional programming in general, but I mean, this is a more, okay. So this is a way to look at it. I mean, okay. So now that we're going to start to explain. Okay. So now that I'm going to start to explain how to program this without object orientation and without objects at all, and no methods, no classes. And let's first start pointing out what the problem, what a few problems are here that I can see, or things that I find strange. So here's one thing. Is so there are two contracts with the Oracle. The Oracle guarantees that it'll read. The Oracle guarantees that it'll call a method of a name set pause with the delta, and the Oracle guarantees that at any given time, the arrow will be at x and y. Now, did you see what's going on here? Is that, look at what's happening. We are then in the middle of this this dance, right? We're put right in the middle, and we're told, oh, now go ahead and write. There's no way to do this well, I think. We're told, now go ahead and write set position. And through that, you're going to be given a triangle, and then you go ahead and set the x's. And there's a contract here that says, I will give you these triangles when the mouse moves. And then there's a contract here that says, I will set the cursor on the screen every time x and y changes. Okay, let's keep this in mind. In fact, I'm going to leave it over here. And let's think of another way of doing this. I'm not going to totally leave it here. What I'm going to do is calculate this, because I didn't want to screw up my copy paste. Okay. Oh, really? Of course, yeah. Okay, that accomplishes it. Okay. So now let's see how to do this in functional programming. So nowadays, the current technique for doing this in functional programming is this. So first of all, we need to understand that we don't have objects, right? So objects are an abstraction, and if everything you model is in terms of objects, then all you get is things that have a shape of an object. But in functional programming, we're not bounded by objects, so we can invent anything. We can invent objects even, and we choose not to. And we can invent anything, any other abstraction. And so let's go back to the tablet. Here's the tablet, right? So it sends these pairs of natural numbers to a port on the computer, right? The computer's right here. actually. That is cool. Okay. Okay. So now we have the tablet, and then we have this, right? This is happening. So instead of objects, what we're going to do is we're going to say, and we cannot have anything that changes, right? So I can't say that, oh, I'm just going to say that there's an X and a Y, and then at each given time, if you ask what X is, it'll be different already, right? And then you can just go ahead. So then now all I have to do is like say that set position is equal to mouse.x and mouse.y, right? And then I could just say, oh, and then x is promised to change over time. But that still has to change, right? Then x is something different all the time. That doesn't solve anything. So we don't want to do that, because the promise is don't change anything don't change in the original, which means don't change anything, because you can't change anything. Everything starts being the original. So every time you assign, it's like the only assignment, right? And that's it forever. So if x would be initialized with 0, it would always be 0, and then the cursor could move. And so saying that the x will change all the time doesn't solve this. Okay, so we need a different way. So that's when not having objects comes in handy, because we're free to come up with our own abstractions. Okay, so what if, and okay, so what if instead of using the abstraction of what is it? The event machine, right? Yeah. Instead of using the event machine, what do we? Because the point is we're interested in the where we draw the line between what the programmer needs to know and what they don't need to know. And so here's how we're going to model this. We're going to say that, so we have to create something that does not change, because we cannot have change, but we still need something that can model the position over time. So what we're going to say is we're going to create something called a signal. So a signal is a concept, right? Like objects are a concept. But they're the only concepts that gets most of the attention, like 99% of the time, right? In object orientation, especially. But in functional programming, there are several concepts, and we can create a new one. And we're going to create a new one now. This one is going to be called signal. And here's what a signal will be. A signal is a value. So in this case, the mouse will be a signal. The mouse position will be a signal. So the value will be a pair of naturals, right? That's what the signal will have. That's what the value of the signal will be. But it'll be inside a context. And that context is a signal. So what does this mean? The signal never changes. So the signal is always the same. And it offers a way for its values to be sampled. So that is not to say that you can come in and take a look to see what the values are at any given point in time. No. It offers a way for the values to be sampled. That means you can choose to connect to the signal, and then you can be listening to it all the time. It's like tuning in the radio, right? So you either have the mouse position or you don't. But you never have like an X and a Y. So nothing's being assigned to. So we can make the mouse position be a signal of a pair of natural numbers. But how do we change it, right? We still haven't answered, like, how do we change these numbers? Well, that's the thing. These numbers only change within the environment. Wait, I don't think that's what it is. Okay, here's a better way of explaining this. In fact, let's delete this. Okay, so let's keep with the mouse position, and we want to model it. So let's first go one level up and think of it this way. Let's say we want to print to the screen what the current mouse position is at any given time. So we want an updating text that always has the position of the mouse, and as I move along, then the number changes, or the numbers change. Okay. And then I have this mouse dot position signal. That is a context. So the signal is a pair of naturals in the context of a signal, right? That's what the mouse position is, a pair of naturals in the context of a signal. And now I want to show it on the screen. So I have a function that prints so let's say print, and this function will get an X and a Y that are natural numbers, and what it does is it prints them. It goes ahead and prints them like this plus show. I don't want to specify any programming language, but and so on, right? All right. Okay. So the pair here is we have a function that takes a pair, and nothing changes in the language, right? So this signal doesn't change. So okay, so the signal doesn't change. So that means we refer to only mouse.position, right? Because it's always the same, so you just refer to it. And it makes no sense to like assign it to a variable, because every variable that you assign it to will always have the same value, which will be the current mouse position, right? So it makes no sense to assign it anywhere. So how do we print the current mouse position to the screen? Well, there's a function, there's a way there's a way to insert a function into the signal context, and then apply that function, let's say f, apply that function to the value inside the context. And then what you get is, now you have a signal of a function of that value. So you can do that, right? So you can compose things like that. So it's not that you're changing the signal, it's that you're making a new signal that has the f. So remember, right? So it's as if I had copied and pasted that, which I should be doing to reinforce the point. But it's as if I had a thing here without the f, right? Even though it looks like there is now. And then I copied and pasted it and I added the f, right? So this is a new signal. So I can say that my program main will be this, right? Will be, but except that print instead of f, right? Print. So that's my function main. Because why? Because main takes a signal. It is of type signal, right? What does it mean to be a type? We're going to talk more about that later. But what it means is that this is what we just modeled. This is what we the concept that we came up with. And what is the concept of signal? The concept of signal is a value that changes through time. Now, I remember saying that we can't change anything. So what's up with changes, right? Nothing gets reassigned here. So you see? So there's no x and y that changed values. So these values, they don't exist outside of the context. Right? And you can choose to apply a function to the values, but they're not here. Like what you're seeing is just the end. So it's like programming with variables, but the variables are given to you. So you're told, okay, if you apply a function to these in this way, if you inject a function here, if you inject a function in my context, then every time there is a new pair, I will apply your function to it. And I will be your signal. I will be that signal. The signal that does what your function does. Instead of just the value. So you can make the signal of the mouse position be a value on the screen by inserting the print function, right? Which is hidden here in this mess, right? So it's print of two naturals. Now here's the thing. This is an n, right? Do you see? So nothing changes, right? This is never a 500. This is never a 400. You never see them. You don't see them. You just promised. But the contract is when this program is run, when it is run, when the program is run, I, the oracle, I will change the values. I will change them. You, programmer, you don't have to change anything. You don't have to concern yourself about changes. In fact, that change is completely opaque to you because I'm going to say that change is simply like two naturals. I'm going to say nothing changes. All you have is like these two naturals. You can do whatever you want with them, but you're doing it with all of them, whatever they are, when I change them. Do you see the change in perspective? Now the oracle is making the changes. So the oracle now is in charge of making the changes. So that's an interesting turn of events for the oracle. Why? Because the oracle, in days of yore, in past times, what the oracle used to do is, it used to, what did it used to do? I don't remember. I think it was different. What it used to do is, it used to make objects, right? Yeah, right, that's right. It used to create objects, instantiate objects from classes, and what else would it do? It would do the inheritance mechanism, it would do initializations, constructions, destructions. It would do method missing. And why would it do these things anyway? Because we created these abstractions and then we assigned it to the oracle to do. Okay. So the abstractions that we created in OO, we then assigned the oracle to do. So then we don't use the abstractions. The objects are for the oracle. I mean, the constraint there of using objects is just because that's all the oracle understands. If all the oracle understands is objects, then your abstractions can only be in terms of objects, because I have to participate in this mechanism of the oracle. So the oracle knows too much if it understands objects, and then I can't communicate. I can't build on top of something that is that can be combined in more ways, right? Because objects can only be combined in a few ways, right? You can do inheritance, or you can do composition, and a few design patterns, and that's it. And then you constrain to those ways of combining things, and you constrain to those abstractions that you can make with objects, and if you can't, you have to stretch them. You constrain to those because that's all the oracle understands. That's all it understands. And it understands so much that it gets blinded, right? Because it knows so much. And it doesn't know that maybe you could do more with less. So in the case of the signal, all the oracle knows is it watches the input. That's why it's an I. It's an I now. It watches the input. So the user is like, typing furiously at the keyboard, right? A dissertation or whatever. And using their tablet a lot, not the mouse. They're using their tablet a lot and like drawing and really drawing a lot, right? And the oracle is like watching all of that intently. And going, okay. You're moving the pen, okay. You're pressing the keyboard, okay. I'm gonna tell all of that, and what I'm gonna do is everything that I see, the oracle, everything I see, what I am going to do is I am going to send it through whatever function is defined in this box. And if it happens to be print, then the screen will get the current position of the mouse every time through time. And the programmer doesn't have to change a thing, because the programmer is simply all he sees, or she, all they see is two naturals. They go, well, I can print two naturals. Sure, yeah, go ahead, programmer, print two naturals. But you can never know what they are. You never know what they are, right? And print being here is what I was calling sampling before. So print is sampling the signal, the value of the signal, right? Which is another way. It's in the same way that we say that there's no assignments in functional programming. There's only binding, and in the same way, I'm saying you don't read the value. Print doesn't read the value X and Y. It never knows what it is, ever. The contract is the oracle says, when this is run, I will replace the two naturals, but only when it's run. But as in programming time, these values are nothing. They're nothing. They're just opaque. They're nothing. There's literally a natural symbol like this number. Natural. That's all. Okay. So this is how we solve the mouse problem, or in our case, because we want to be functional, this is how we solve the tablet problem. Is we model the port as a signal, right? So if the port is a signal, that is this signal, right? So now the port is a signal of two naturals. Then all we have to do is insert set pause into the signal. And what is our set pause? Our set pause is it receives the absolute x and y, and what it does is it divides it by 100, remember? Because our tablet goes from 1,000, no, goes from 100,000 to 100,000, right? So it goes 1k across, 1k, yeah, down and 1k across, right? And our screen is only 1k to 1k. So our set position simply divides 100 by 100. So that is the function that we insert into signal. So really, set position is only called set position as an artifact, right? So we shouldn't call it set position because it's not. What it does is it converts, right? That's what it is. So what it does is it converts position. Because what it's converting, it's converting the position of the pen on the tablet to a position of the cursor on the screen. So it is more of a conversion than anything else. Now, every function is more of a conversion than anything else. But that's a stronger point that I'm going to make later on. But what's important here now is that we see that we can actually model the mouse, tablet without state. And it turns out that we can actually also model the mouse without state if only we teach the oracle another trick called remembering. But that we can look at later. This is turning out to be really cool. This is a cool oracle. I might save this oracle. Actually, I won't. No, I don't like it anymore. But if we teach another trick to the oracle, not only. If the other trick that we teach the oracle is remembering the previous value, that's all that we need, because the oracle, we don't want the oracle to know a lot, so we don't want it to like remember everything in the past, right? Because then it becomes slower. It's slower to think, so we don't want to overload its brain. The oracle is old, and slow, like oracles are. So here's what we do, is if we teach it to remember the last value, then we could model a mouse. So how would we model a mouse with remembering the last value? Well, it's very simple. So here's the oracle. Alright. And the oracle now knows two tricks. Well, it knows one trick, which is calling a function every time something changes, right? So it knows change. So that's what it knows. It knows a change call, right? That's what it does. It does change calls. So every time a change happens, it calls something. That's what it knows to do. So that's what the oracle does. But something else we want to teach it is how to remember. And that's not how you spell remember. How to remember the last of something. So remember last. So if we can remember last, then the way we model the mouse, and I'm going to explain this briefly because I'm going to go much more in depth in a later video, but just as a quick explanation, we're going to say that the mouse is here and it sends deltas, right? It sends triangles. And we're going to say that the port that receives the triangles is a signal. So the port is a signal. Okay. Right. So the port's a signal. And triangles go in there. And what we're going to do is we're going to say we're going to call that same set position that takes an x and a y, right? It divides by 100. So we still have that one. We still need it. Or actually we don't. I don't think we do. No, because it's not a thing anymore. Yeah. Okay. We don't. So our set position will be a different function. So it'll get the x and y. Why am I doing this notation? Oh, sure, that's right. So it'll get an x and a y. And this is what it'll do. It'll say, well, actually, that's not right. Hold on. Yeah. So it's got two naturals here. And this is what we're going to insert into this. We're going to insert a thing called set position. All right. And here's the definition. What set position does is it remembers the current position. No, what it does is it modify cursor by delta, and then remember cursor position. Okay, so the trick that we are going to teach the oracle, remember last, what it does is the oracle will understand two commands, modify and remember. And modify, what it does is it takes a signal and then it changes the value of that signal, right? So the cursor is a signal. It goes ahead and changes that value by some delta. So remember, we are not allowed to change anything. The oracle can change anything. So the oracle is allowed to change, but we can't. So that's why the oracle we teach the oracle a trick, but what we get from that is that we don't have to do it, right? So we don't have to change the thing, and the reason we don't have it, it's that's the promise, right? Remember, we can't, right? So because we realize it's good, there's some benefits, so we're not changing anything. So modify cursor delta doesn't change anything, because we can never know what the cursor is at any given point, right? That is how we know. That's how we know we cannot change it. That's how we know that someone else is changing it, right? Because you might think that it's a trick. It's not a trick. We can never ask what the current position is because there's no current. Because our functions will be called several times a second, right? Whenever there's a change, so potentially several times a second. So that's why we're never changing anything, but we can ask the oracle to change the signal for us, and then it goes ahead and changes that. So we say, so the function set position is oracle, go ahead and modify the cursor by the delta, and oracle, go ahead and remember the cursor position. Okay. Now modify already encapsulates remember, I think. But in this case, if we insert it in signal, it'll have another shape, I think. I don't know. Because I was trying to use fold P, but I don't know how to explain in a way that I can understand and explain at the same time. Yeah, so remember the Q. We never drew it, but this is a Q. Put things in there, and things come out. When I say remember here, I mean yeah, I don't think remember is needed here. Only if I were to write this in a different way. Yeah. Remember is used, sure. Remember is used from the outside. So modify is if you're inside, then you can say modify here. In terms of something, I guess. No, but you'd be inside the other signal, I don't know. But remember from outside definitely takes a function, right? So that's fold P. It takes a function. And it takes a signal. And a function that produces a signal or something like that, I don't know. But yeah, that's the idea. So yeah, it's something like that. Okay, so let's recap. So this is the object-oriented way of doing it. Okay, initialize, and what else do you do? You know, you gotta put it in the middle of the screen. So set pause, screen dot middle, and then set pause, which I never remember to do the def. And this receives a point. And what we do is we assign however, we have to do an if. We're gonna say screen.x, right? Being very charitable. Within screen.y. Alright. So this works. This handles the case of keeping the cursor inside the screen, right? So it only changes, so it starts in the middle, that's fine, and then it only changes if it'll actually be within the screen. Where does the screen come from? Well, the Oracle will have to explain that to you, right? And I'm sure it's going to be some other promise. It'll promise that in some other object, there's some other object called a screen, and it'll promise that it'll always change the values of x and y to the right values, and that you can then come here and check them out at any given time, you know, once or twice or 3 times, or later on, or before dinner or whatever. You can come here several times and ask the value, ask away, and each time might be different, you know, depends. And it's just another object, just like mouse, just like the one you're defining. Anyone can ask where the x is and where the y is, right? This is should be cursor, by the way. I don't know. Well, we were modeling the actual mouse, and that's fine. But yes, so but anyone can come in here and ask your x's and y's, and all you're telling them is like, okay, yeah, when you ask, it'll be the current x at the time that you asked, and that's all that you guarantee, right? And that's because the oracle, all you taught the oracle was about this mechanism of what? Well, you taught the oracle about objects and methods, and you taught the oracle about how to instantiate classes, right? But you never taught the oracle how to, what is it? So mouse and screen. So if it's tracking the position of a window, then when the mouse drags the window, I get a message. Oh, but the operating system does it for me. Okay. Sure. So what the oracle knows, and it knows so much. What it knows is it knows how to call messages. That's what it knows. And that's what all it does through time. So if your program happens to be running and it sends a message to the screen called middle, then you know it'll grab that message and it'll send it to screen, and then screen will reply, and then it'll send it back to you. That's it. That's all the oracle knows, is how to route messages back and forth, right? Back and forth, back and forth, right? But it only does that when you ask. When you ask. And if you want to ask all the time, then what you have to do is you have to make a loop. And what a loop is another thing that you well, how is a loop in it's a special message? No. I don't know how a loop is in proper repeat 5 and then repeat. Yeah. Repeat. And then for each it takes a block. Well, yeah, but then it does it in a functional way. Huh. Yeah, the best approximation of a loop in proper object orientation would be 50, then you send the message repeat, and then you send it a block, but that's not really good. You'd have to send an object and a method, right? And then it would call this object, then it would make a loop. But that's the only way. So the oracle does not understand the concept of like, no, but just keep calling it. Just keep calling it. It doesn't understand because you never taught it. Okay? So it only knows things about object orientation, that classes and instances, but it doesn't know these useful concepts like, well, just call my function all the time that something changes. Just call it for me, right? It doesn't know that. Okay. So here's the functional oracle. Okay, here it is. And here's our program in the functional oracle, right? Here's our program. It'll be something like main equals, and we're gonna set the position, right? so it's not an even main. So we want to write set position, right? And apply it to the port. Because here, where's the port here? No, we're just assured that this will be called. Okay, so in the object-oriented version, we're assured, the Oracle assures us that it'll call set position. Okay. So our function just ends up being the function that we're assured it will be called on mouse position every time it changes. Since our Oracle knows how to call something every time something changes, then our function is simply okay, so I don't want to call it calc because it's ugly. Our function is mouse to cursor, and it takes an x and a y, and it outputs x over 100 and y over 100, and that is the functional version. And that takes care of boundaries. I mean, provided you've chosen the right numbers. That takes care of the fact that the cursor will always be within the screen boundaries, because you're automatically converting the size of the screen that we agreed on being 1,000, and you're converting that from the tablet's position, which we agreed goes to 100K, 100K. So that conversion is this arrow. That conversion from tablet to screen, 1,000 by 1,000, is this. And that is how you move the mouse in functional programming without changing anything, is by taking this function and inserting it into the mouse dot position signal. And a signal is something that the Oracle understands and has a contract with you, the programmer. And the contract is, listen, if you insert a function in a signal that I have, in this case, we're talking about the mouse position signal. There are several other signals that it has, like the keyboard state, right? But this is one of them. And the Oracle is saying, listen, programmer, you know, I have this signal, and I am always going to update this signal with the mouse position. If you want, you can put a function there, and then every time I update it, I can call your function. I can call your function for you. I mean, it's not a problem. So the Oracle is cool. And we give it mouse to cursor, and bingo, what it does is it sets the cursor position, right? I mean, we're missing the we have to write, actually, modify cursor. Okay. Alright. So this is the function, right? So that's the function. Function is modify cursor, move to cursor, and mouse to cursor, mouse to cursor, right? Modify cursor, mouse to cursor, and mouse to cursor is this function. And then we put mouse to cursor inside the signal, and mouse to cursor will be fed the x's and y's as the signal changes, thanks to the Oracle, courtesies of the Oracle, okay? Because it's not charging us for it, so it's doing it for free. It's retired, so it's fine. So it promises us that, okay, we put a function in here, it'll call it every time mouse position changes. So we put this function, mouse to cursor. What mouse to cursor does is it changes. What mouse to cursor does does this. It modifies cursor with the X and the Y. Ah, I freaked everything up. Let me see if I can do a bunch of them. Is that the limit? It's probably the limits. Okay, we can't control Z anymore. So modify cursor is the call would be modify. Yeah, I'm not making the case here at all. Making this more confusing. So modify cursor, and then it would take the delta that you're given here, right? Which is not a delta, it's a position. Yeah. So it's given the position that the signal gives. So the signal gives out a position that is a mouse position, right? And you're saying, give me, so feed that position to mouse to cursor. And mouse to cursor, its implementation is, the implementation of mouse to cursor is modify cursor with this, which is not then modify, it's update, update, update. So update the cursor with this position. And it divides by 100. Yeah, I'm confusing this, but you see the point. And we say we're telling the Oracle, update. Hey Oracle, go ahead and update. Let me try this again. Let me try this again. Give me a second chance. Give me a second chance. I want to try this again. I want to do this right, you know. All right. Okay, so here's how we do in functional programming. So functional programming will do the following. The set position function takes an X and a Y, which is a point, and its implementation is it'll update the cursor to be X and Y. And so the Oracle, let's go around. Oracle, go around, go around. The Oracle knows how to update. That's what the Oracle does. We don't update anything, remember. This might look like we're updating it, but the proof that we're not is that we cannot see the values, right? So you can never, so let's say the mouse is at 500, 500. You can never know from your program. So the values don't leak out. So that means that update is a function that takes a signal. So cursor is a signal, right? And you're saying update that signal with these values. And because the Oracle manages signals, and then it goes, okay, sure, goes ahead, puts X and Y there, and then that moves the cursor, and what you do with set position is you put set position, you put it inside the what's the other position? The screen. No. No, I've already done that, yeah. Yeah, I think I'm confused on this. Sure. Yeah, you put set position in the mouse. Sure. So, yeah, that's what I'm confused. So there's a mouse signal that gives the position, and you put set position inside, right? So now set position is inside the mouse signal, and it's reading the mouse signal. So every time the mouse updates its signal, then the oracle will do whatever set position says, right? And set position says, well, divide the freaking values by 100, which I keep forgetting to do. And then update the cursor position with those values. So the oracle will do this, perform this inside the signal, right? It'll basically change the signal. So it'll be a function that ignores its arguments, because the arguments will be whatever the cursor is now, and then it replaces the cursor value with these. But that's something the oracle does. And because we can never know what is an x, like there's no way in the program to obtain an 8 from an x, right? There's no way. So we can only apply, we can choose to apply functions to these changing values, and we can choose to tell the oracle to change them. But we can never know where they are. So the effect of those changes are, I mean, we're not changing them, but there's no effect, right? So that's how we accomplish it in functional programming.